Hey guys, welcome back to another Algebra 1 lesson. Today we're going to talk about dilations, and we're also going to talk about reflections. So let's get started. A dilation is nothing more than stretching or compressing the graph of a function. So stretching, compressing, I think of stretching as getting tall and skinny, compressing, it's smashing it like a pancake, making it wider. So when I'm talking about this, if I have the parent function, y equals x or f of x equals x, if I want to stretch that or compress that vertically, what I'm going to have to do is change the slope of the function. So I change the number in front of the x, that's the slope. If my slope is greater than 1, the parent function has a slope of 1. If it's greater than 1, the absolute value of it, then it gets stretched vertically. It gets taller and taller and taller. We can look at this on this video. We've got the slope is 1, the number in front of the x is 1, but if I multiply that and change a to a number whose absolute value is greater than 1, then it stretches it vertically. Okay, on the same token, if a falls between 0 and 1, the absolute value of it, so if it's a fraction like 1/2, 1/4, 1/8, what that does is that compresses it. It makes it go down towards the x-axis and it changes the steepness. It makes it less steep. So multiplying by a number greater than 1 makes the absolute value, if the absolute value is greater than 1, there we go, multiplying by a number whose absolute value is greater than 1 stretches it, makes the graph steeper. Multiplying it by a number between 0 and 1 makes it less steep. It stretches it out and makes the graph have less steepness to it. So we can look at this. I'm getting all kinds of tongue-tied today. This has a slope of 1. I change that value to a number in between 0 and 1, and we can see that it is less steep. There's less of an incline. Okay, so let's look at some examples here. It says, describe the dilation in g of x equals 2 times x as it relates to the graph of the parent function. So again, this is going up 1 over 1, up 1 over 1. If we put a 2 in front of that, we know now it's going to go up 2 over 1, up 2 over 1. So the slope becomes steeper. My line is going to have a bigger incline. It's getting stretched vertically. We can look at this. When we graph it, there it is. We went up 2 over 1, up 2 over 1. So because we're multiplying by 2, the positive constant a is not grouped with x, and the absolute value is greater than 1. So the graph of f of x is stretched vertically by a factor of 2. It's a vertical stretch of the graph of the parent function, and the slope is steeper. All right, so let's look at another example here of a horizontal dilation. So that was a vertical dilation where it stretched upward. So let's think about the dilation if I multiply it by 1/4, 1/4 x. Well, if I change that value, this is my parent function, up 1 over 1, up 1 over 1, up 1 over 1. But I change that to going up 1 and then over 4 because the slope is 1/4. Then I can see that my line is no longer getting steeper. Now it's getting less steep. It's getting stretched horizontally. It's getting pulled out this way. Think of a rubber band. If I stretch it vertically, it's getting taller, but if I stretch it horizontally, it's getting wider. So my line here is being stretched horizontally by a factor of 1/4. So again, g of x equals 1/4 is a horizontal stretch of the graph of the parent function, and we can see that the slope is less steep than that of f of x. So now let's talk about some reflections. Reflections we know are like when we look at ourselves in the mirror. The reflection of myself is me. It looks like me. But we also have looked at reflections across axis. And that's what we're going to do. Look at a reflection across the x-axis, look at reflection across the y-axis, and compare these graphs. So a reflection is nothing more than a transformation in which a figure, line, or curve is flipped across a line. Think about looking in the mirror. It's flipped across the line. You're looking at yourself. When a linear function, f of x, is multiplied by a -1 before or after the function has been evaluated, the result is a reflection across the x or y axis. So what's happening is every x or y coordinate is being multiplied by -1. So here we have the parent function, is the blue one, f of x. And if I were to take that and multiply every y coordinate by -1, this is what happens. I've got x comma y. If I times that by a -1, then I still have the same x value, but the y is the opposite, so it flips it across the x-axis. So let's look at this one. Multiplying x by -1, then, what that does is it flips it across the y-axis. Think of our parent function. We have x comma y. We're going to take this x and multiply it by -1. So now it's the opposite. It's on the opposite side of the x-axis, but the y is still the same. I said on the opposite side of the x. I meant the opposite side of the y-axis. But anyway, it's being flipped across. My x coordinate is being multiplied by -1, so it comes over here on this side where x is -1, and the y coordinate we can see is still the same. All right, so let's try an example with this problem. Reflections of linear functions across the x-axis. So we know in order for it to flip across the x-axis, the y values have to go from being positive to being negative, or from being negative to being positive. So let's look at it. What we're going to do is times everything. What does it say? Because f of x is equal to x and g of x is equal to -1, a times f of x, where a equals 1/2. Ooh, we have a fraction and a negative number. So think about what's going to happen here. It's going to change the steepness. Because it's a fraction, it's going to become less steep. And because it's negative, it's going to flip it over. So what we did here was we multiplied it by -1/2. So that stretches the graph or compresses it vertically. It's squishing it out because it's a number between 0 and 1. And it's negative, so it gets reflected across the x-axis. So one more time, the graph of g of x equals -1/2 x is the graph of the parent function vertically compressed and reflected across the x-axis. So let's look at a reflection across the y-axis. It says describe how the graph of g of x equals -3x is related to the graph of the parent function. Now let's think about this. We see that 3 is greater than the absolute value of it, because it is a -3. But if I take the absolute value, it's greater than 1. So we should be stretching it vertically. However, because there's this negative there, we know there's going to be a flip across the axis. So let's look at it. When we do this, if I multiply each of the x values by -3, a -1 times a -3 makes it a +3. 0 times -3 is still 0. 1 times -3 is still -3. So my function becomes, when I plugged in a -1, I got out a +3. When I plugged in a 0, I still got out a 0. And when I plugged in a 1, I got out a -3. So we see there's a flip across the y-axis, and it got stretched vertically because we multiplied by a factor of 3. So it was compressed horizontally and reflected across the y-axis. All right. Oops, I wanted to watch that little video. Let me go back and click on this real quick.
transform linear functions on a TI-84, start by entering the parent function y equals x in the y equals list and graph in the standard viewing window. Use the y bars menu to transform a linear function by adding a value, subtracting a value, or multiplying the parent function by a value. To see a translation of the parent graph, add a value to the parent function. To do this, select the parent function y1 from the y bars menu and add a value. Graph the function. Notice that the new graph is a translation of the parent graph. To see a dilation of the parent graph, go back to the y equals list and multiply the parent function by a value. Graph the function. Notice that the new graph is a dilation of the parent graph. To see a reflection of the parent graph, go back to the y equals list and multiply the parent function by -1. Graph the function. Notice that the new graph is a reflection of the parent graph.
That's a nice little video to sum up the different things that happens. If I multiply by a number, it stretches it or compresses it. If I multiply by a negative number, it reflects it. Oops, I went too far. So let's look at this last example here. And we're going to describe how the graph of g of x equals -3x is related to the parent function. So look what's happening here. We're multiplying by 3 inside of the parentheses. And we're also multiplying by a negative number. So we know there's going to be a dilation because of the factor of 3, and we know there's going to be a reflection because of the negative value. That's the one we just did, isn't it? Apparently, I'm losing my mind. So anyway, that is it for today's lesson. Sorry, guys. I don't know why I didn't catch that I'd already done that. But anyway, that sums up today's lesson. I'm going to post this. If you have any questions, please make sure you reach out to me. Ask for help. I'd be more than happy to help you.